Okay, friends, we're just going to go over this page that you guys completed yesterday. So we're doing page 49, and you guys are going to grade this for me. So if you guys want to get out a pencil or something different than what you wrote with to maybe grade your work or to check to make sure that you are doing these correctly. So let's do number 1 together. Javier has 12 eggs. He cooks 3 eggs for breakfast. How many eggs does Javier have left? So if I start with 12 eggs, I'm going to go ahead and I can make my number bond up there. And he cooks 3 eggs for breakfast. We're trying to see how many eggs does he have left. So with my number bond, I am going to solve that missing number. So I'm going to start with 3, and I'm going to stop when I get to 12. So I'm going to lock in 3. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It took me 9 fingers to get to 12. So I know 12 minus 3 equals 9. So that means C is our answer. Let's go to number 2. And remember, friends, you can always pause this video if I'm going too fast and you need to write these down. Number 2, which equations are in the fact family for this number bond? So I'm going to look at this key little part right here, which equation. So that means I might have more than one answer. So they went ahead and filled out our number bond for us. They said 7 plus 6 equals 13. So our key words here are fact family. We're going to see which equation matches our fact family. So let's look at number 8. Letter A, sorry. 7 plus 6 equals 13. 7 plus 6 equals 13. I have the same 3 numbers, and I started with my 2 smaller numbers to get my bigger number. That one works out. I'm going to go ahead and color that one in. My next one, 13. Okay, I have a 13. I have a 7. Oh, but they have a 20. 13 plus 7 is 20. That is correct. However, are they using the same 3 numbers? They are not. If we start with an addition problem, to use the same 3 numbers, we need one of the 2 smaller numbers, kind of like an A. We use the smaller numbers to get our bigger number. This time they started with our bigger number and added more. That's okay if you want to do that, but if we do that, we don't have the same 3 numbers. So I'm going to draw a line through that one. It does not work. What about C? 13 minus 7 equals 6. Okay, I have 13. I'm taking away, so I started with my bigger number. I took away 7, and I have 6 left. I used the same 3 numbers. In my subtraction, I have my largest number first, so that works out. I'm going to go ahead and color that one in. All right, what about D? 6 plus 7 equals 13. Okay, so I have my addition again, so I need my 2 smaller numbers. I have a 6, a 7, and a 13. It works out too. That looks a lot like our A, but the only difference between A and D are they flipped these 2, and that's completely okay because we have a fact family there. Our last one, E. 13 minus 6 equals 7. 13, they took away 6, and they got 7. Does that one work? You are correct. It does. We have E. Now this one, friends, is a bit more tricky just because we haven't talked about it a whole bunch recently. We've been so worried about fact families that we're going to see if we can, it says, could you make a 10 to solve the problem? So remember when we had our number line at the very beginning, and let's say we started at 14 and our goal was to get to 7? We were like, let's jump back to 10 and then see how many jumps. So, can we jump back from 14 to 10? Since 14 is bigger than 10, we can jump back to 10, so we could make a 10. And then we'd have to jump back again to get to 7. We're not solving it. We're just saying, can we do the strategy of making a 10 to solve the problem? So if we have 14 and we can go back to 10, yeah, we just made a 10 to solve that problem. What about 10 minus 2? So this time, if we start with 10, and I'm just drawing this so you guys can have a visual representation, and we're going all the way back to 2. If we start at 10, can we go back to 10? That doesn't even make sense. We can't go back to 10 because we already start at 10. So for this one, making a 10 would not make sense. So we would color that D as a no. What about number 9? 9 minus 3. If we're at 9, can we go back to 10 if we're subtracting? 9 is smaller than 10, so it wouldn't make sense to make 10 on that one since we're subtracting. So that one's a no again. What about this one? 12 minus 4. Since 12 is bigger than 10, yeah, we can go back to 10 and then see how many jumps it takes us to go to 4. We can do that step first. So yeah, that one would work. So when we're using the making a 10 to solve, we realize that our biggest number has to be larger than 10. We haven't been doing that strategy as much because we've realized we don't need to jump back to 10 and then jump again and add those two numbers together. We found a way to add them together anyways. Alrighty. So on this one, it says solve 12 minus 5 using a related addition fact. Show how you solve the problem. So our problem is 12 minus 5. I'm just going to go ahead and rewrite that problem again. 12 minus 5, and we have our mystery number. We've talked a lot about how we can solve this with using an addition problem. So to switch our problem around, well, we can use fact families. To switch it to an addition problem, we have to start with one of our smaller numbers. So is 12 or 5 a smaller number? 5. So I'm going to start with 5. Plus, we don't know that mystery number. We don't know what it takes to add to 5 to get to 12. But I went ahead and I had to show my related addition fact. So that is my related addition fact. So if I start with 5, we're stopping till we get to 12. So let's lock in 5. 5. We're finding that mystery number. 5, 6, 7, 8, 9, 10, 11, 12. It took me 7 fingers to get to 12. So that means since we found our missing number, we can use our fact families to help solve this one because we have the same 3 numbers. So 12 minus 5 equals 7. All right, number 5. It says show a way that you could find 16 minus 9. You can do this a variety of ways, but I kind of like our number bond that we've been practicing the past few days. So let's say we have our 16 and we take away 9 of them. We need to figure out this mystery number. This, friends, is this exact same strategy we're doing here. I just wrote it in a number bond way rather than writing it out. So if I want to write it out, I could do 9 plus our mystery number equals 16. So to find that mystery number, what I'm going to do is I'm going to start with my smaller number, which is 9, and I'm going to stop until I get to 16. So let's try it out. 9, 10, 11, 12, 13, 14, 15, 16. It took me 7 fingers again to get to 16. So if I'm filling in my numbers, I know I'm originally solving 16 minus 9. I have my 16, I have my 9, I have my 7. It equals 7. What are 2 ways you can find 17 minus 8? So, friends, we can do what we just did. We can do 17. We can do our number bonds. We can use fact families. So if we change that one, we're going to start with changing our subtraction problem into an addition problem. So that would be 8 plus our mystery number equals 17. So I can use it by using my number bond, or I can do it by using my fact families. So let's start with our number bond. We're going to lock in 8 and stop when we get to 17. So lock in 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It took me 9 fingers to get to 17. So I can just look at my number bond and say 17 minus 8 equals 9. That was one way I can solve it. And another way, I'm going to lock in 8 and stop when I get to 17. Lock in 8, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I got 9 again. And I know if 8 plus 9 equals 17, that's a fact family. So I know I have my 17, I have my 8, my 9 goes in this box. I just showed you 2 different ways to solve. If you can do a number line. You can do a make 10. These are just 2 different ways to solve. All right, friends, what I'm going to have you do next is you guys are going to try out page 53 for me. Solving one-step word problems. So it says Seth has 9 grapes. His dad gives him some more grapes. Now Seth has 15 grapes. How many grapes did Seth's dad give him? So friends, this is a brand new lesson. So remember how at the beginning of a lesson we kind of feel frustrated a little bit? We're like, oh my goodness, I don't know this. Well, guess what? The power of yet. We don't know this yet. So I'm just going to have us practice. At the very beginning, we always just see what we know. So I want you guys to see, how do you think you would solve this? You can use counters. You can use 10 frames. You can draw a picture. There's no one way to eat a Reese's, folks. So I want you guys to show me, how would you solve this problem? If I gave you this problem, how would you solve it? And that is the only work you are doing independently. All right? Good luck, friends. You got this. We will talk about it tomorrow.